All right, hi, here we are for the second lesson on section 7.3 with partial fractions. So on the last lesson, we focused on the first learning target, which was I can set up a partial fraction. We did one problem for learning target number 2, which says I can solve a partial fraction decomposition. So today our focus is going to be on that learning target number 2 once we get into the lesson. Our purpose is the same, so we're doing partial fractions with our videos and online practice so that you can find functions and rates of change in calculus. So again, the goal of this class is to make you successful in calculus, and this is going to help. So what I want you to do is a warm-up. Let me fit this to the height. All right, so I want you to try 1, 2, 3, 4, 5. These 5 problems as, that's a 1 by the way. A quick check of how you're remembering with setting these up. So you did the homework for it, but just to get some more practice. So go ahead and pause the video and try just your setup for these 5 problems. Okay, hopefully you tried those out. So now here are our answers. For the first one, we had non-repeated linear factors. For the second problem, we had a repeated linear factor, so we had to do one of them, then 2 of them. Both constants because they were linear, and we were going 1 power down. Third one, we have a linear factor and a repeated linear factor, so you can see that with my constants. In the fourth one, we have a linear factor and a quadratic factor. So we used a constant a. Since this factor itself was quadratic, we had to use a line, basing it off of our y equals mx plus b. We have bx plus c. And then here we had a repeated linear and a quadratic. So the linear gets 1, then 2, okay, both just with constants up top. And then this factor itself is quadratic, so we put that linear up top with a cx plus d. All right, so hopefully that went well. Last class, we solved all the way through this problem. So we did our decomposition and we got our final answer. So I want to work through probably 2 more problems with you and then have you try one. So we'll use the same problems that we saw with our cases. So here was case 2 where we looked at repeated linear factors because now I want to aim for that second target where we said actually solve the decomposition, which means work all the way through. All right, so we have our setup we talked about last class. So now I'm thinking about this as an actual equation with 2 sides, okay? So I'm going to multiply through by that common denominator, which is x times x plus 7 squared. All right, on the left-hand side, that's just going to leave me with 3x squared plus 49. On the right-hand side, x is going to cancel with the x. I'm going to have a times x plus 7, quantity squared. The b term, one of the x plus 7's cancel, so I have an x and 1x plus 7. With the c term, both the x plus 7's cancel, but I have an x. Remember my trick that I showed you how you can write the common denominator above each and physically cross it off, if that helps you. So now we need to do, a lot of this is going to be in the algebra. I personally adore algebra, so I hope that's okay with you. Here is my a, then I'm squaring that out. X squared plus 14x plus 49. Remember that you can't distribute a squared there. You have to actually FOIL. Then we distribute here, bx squared plus 7bx. Looks gross, but that's okay. Plus cx. We distribute out our a. We have ax squared plus 14ax plus 49a plus bx squared plus 7bx plus cx. I'm sure you're thinking that looks nasty, but it'll be all right. Looking for like terms, we have our x squared and an x squared there. Looking for my x terms, I have that, and that. And looking for my constant terms, I just have that. So we group them together. still have my 3x squared plus 49 hanging out on the left. So I'm going to group them. I have an a plus b that goes with my x squared. I have, with my x term, I have a 14a. I have a 7b and a c. And then only one little green guy there, 49a. All right, so if I'll use those same colors to stay consistent, think about these two sides of the equation actually have to equal each other, okay? All these variables that I came up with have to actually give me that fraction when I bring them together. So that means a plus b is with the x squared. It has to give me 3, okay? So I can write a plus b has to equal 3. Okay, and then I say, all right, for my x terms, 14a plus 7b plus c has to give me, there's nothing there. What does nothing mean? 0. So 14a plus 7b plus c has to give me 0. It has to go away. That x term is not supposed to be there, right? And then last one here, the constant 49a has to give me 49. So here, I'm going to say that 49a has to give me 49. So see how we're pairing up those sides. So now this is my system. Now it should make sense that we did systems of, 3 equations with 3 unknowns before this. That's what we were gearing up for. So sometimes you have to do the full process. Sometimes, look for shortcuts here. Woohoo, I can divide by 49. I get that a is 1. I can plug that in the top equation. All right, let's not forget that a is 1. 1 plus b is 3, so b is 2. Yay! And then I get 14 times 1 plus 7 times 2 plus c is 0. So that doesn't look pretty, I'm sorry. That's 14 and 14, so 28 plus c is 0, so c is negative 28. So final answer looks like writing those coefficients now in my original setup. So 1 over x plus 2 over x plus 7 plus, you can put plus negative 28 or you could put minus 28. Either one's fine. X plus 7 squared. There's problem number 1. You're probably thinking, wow, that takes a little while. Yeah, these are not the shortest problems ever. But there they are. So those fractions, if I made the common denominator and brought them together, would give me what I started with. In calculus, when you go to do the derivative, it has to be in pieces, in like its prime. If you picture doing like a factor tree back when you were younger, that's kind of what we're doing here. We're like factoring it down to its prime pieces. So there you go. All right, let's look at case 3, which was distinct quadratic prime vectors. So we had, remembering how to factor a cubic, and then we had broken it apart into its 2 pieces. So we're going to pick up right here to actually solve through. Again, this is learning target number 2 now, where we are looking at solving for these partial fractions. Okay, so I multiply through by the common denominator. On the left-hand side, I just have 3x minus 5. My a is left with x squared plus x plus 1 because the x minus 1 canceled. My bx plus c is left with an x minus 1. Okay, so now ax squared plus ax plus a plus You may stop liking me after this problem, but it's okay. Just think you're distributing out to each of the terms. You're just foiling. It just looks weird. Bx times x is bx squared minus bx plus cx minus c. I want you to pause here and think about how many chances there are in these kind of problems for mistakes. And I want you to be really, really careful when you solve through them, because finding your mistakes is a pain. So keep that in mind. Be really careful. So I'm going to bring together my x squared terms, my x terms, and my constants. I like to write it in factored form. You don't have to. If this doesn't help you, this step here, you don't have to. I think it's helpful though. Because you're really looking at your constants as, you know, the pieces of that equation that you have. All right, ready? So we have our x squared term. Oh no, there's no x squared term. What does that mean over here? It means a plus b has to give 0. Okay. Next, we have our x term. So a minus b plus c has to give me 3. And then my constant, a minus c, has to give me -5. I no longer like my color choice, but that's going to have to be okay. They look ugly together. It's okay. I can deal. Okay, so now this is my system. I have to solve the system to figure out my partial fractions. So think back to the first section that we did, section 7.2, with our systems with 3 equations. This already just has an a and a b, so I'm going to keep that. And I'm going to use these 2 equations and eliminate c, because there's no c in the top one. So I'm just going to add straight down. So I have a plus a is 2a. Negative b plus nothing is negative b. C's cancel. And 3 minus 5 is -2. All right, so a plus b is 0. 2a minus b is -2. I'm going to add straight down. B's cancel. A plus 2a is 3a. And 0 minus 2 is -2. A is -2/3. Yes, you can get fractions. So I'm going to plug into the top equation. A, which is -2/3, plus b is 0. So b is +2/3. And a is -2/3. Minus c is -5. So negative c is -5 plus 2/3. I'm going to make a common denominator, give that a 3. So that's -15 plus 2 is, there we go. -15 plus 2 is -13/3. So c is +13/3. All right, I'm on a 15-minute time crunch on my video here. So what's that look like for my final answer? -2/3 is my a over x minus 1 plus 2/3 x plus 13/3 over x squared plus x plus 1. What's a nicer way of writing that? Bump the 3 down. -2 over 3 times x minus 1 plus 2x plus 13 over 3 times x squared plus x plus 1. That was a doozy, but we made it.